Alright, students, one more radical equation example, and this will be the last one for the day. Alright, in this case, as you can see, the one thing that you want to notice is that you got multiple terms of radicals. In this case, you got 2 on the left side, 2 radical, and you can't just square both sides of the equation as is, because then you end up with cross terms are still going to have radicals, and then you have radicals times radicals terms, and that's going to get very complicated. So what you would do, the strategy here, when you notice that there are multiple radical terms in the equation, you can separate them a little bit, right? So in this case, I'm going to move the negative square root of 2x to the right side of the equation. So here it goes. I end up with square root of x plus 9 is equal to 3 plus square root of 2x. So there you have it. So in this case, then I'm ready to square on both sides of the equation. So I square on both sides of the equation. Square on both sides of the equation. I can get rid of radical, so I end up with x plus 9 on one side, and on this side, I make sure I follow the binomial expansion, right? A plus b squared is equal to a squared plus 2ab plus b squared, right? So what that means is a squared, a is 3, so 3 squared plus 2 times 3 times square root of 2x plus square root of 2x squared. Okay, now so now we're gonna clean this up a little bit, and so we end up with x plus 9 is equal to 9 plus 6 times square root of 2x plus square root of 2x parentheses squared. It just becomes 2x. So now I'm at the point where I can combine like terms, right, and move everything, leave the radical on one side and put everything else on the other side. So I need to get rid, if I want to isolate this term, that means I need to get rid of 2x, I need to get rid of 9, but by doing so, I need to do the same thing on the other side as well. So I want to get rid of 9 minus 9 on both sides, minus 2x. Okay. So equal. So on the right side, I end up with 6 square root of 2x. So that's fine. On this side, x minus 2x is negative x. So we end up with a negative x right here. So that's our new equation. It's a transformed equation. All right. So, but right now I need to get rid of the radical. So I can, again, this is basically the kind of equation that we have in the first video. But basically it's a equation where you had to do the square on both sides of the equation 2 times. Right. So in this case we did it 1 time and write this step. But see, doing 1 time, I only got rid of 1 set of the radicals, but now we got another radical that you still have to deal with. So we got to transform this again. So it's a double transformation. So we got to square on both sides again. Make sure you're very, very meticulous with your notation so you don't drop any number. So negative x squared just becomes x squared. That's pretty simple, right? In this case, this is a 6 square root of 2x parentheses squared. So the 6 gotta get squared as well, so it becomes 36. Square root of 2x squared becomes 2x. You see, very, very, very. You gotta pay attention to your notation so you don't get confused. So in this case, we end up with x squared is equal to 36 times 2x, which is 72x. At this point, you got to move everything on one side now. This is becoming a quadratic equation, so we end up with x squared minus 7 T2x, right, equal to 0. So then you apply the principle of factoring. You use the technique of factoring. You factored out x. So x, factor out, you end up with x minus 72 in there equal to 0. So now this is a very simple equation to solve. We know that x is equal to 0 or x is equal to 72, right? Or x minus 72 equal to 0. So you end up with x equal to 72. Makes sense, right? Now we have two answers, but we got to check with the original. Again, so I'm going to bring the original to this side so that we can have it readily available to look at. So it is square root of x plus 9, and then minus square root of 2x, and then we're going to see whether it's equal to 3 or not. So bring the 0 down here. I'm going to, as you can see, my finger is placed on the x here. So put square root of 0 plus 9 minus square root of 2 times 0, and equal question mark, is that equal to 3? Okay, let's see. Square root of 0 plus 9 is equal to square root of 9, which is square root of 9 is 3, minus 0. Yes, 3 is equal to 3. Makes sense. So x equal to 0 is one of our answers. Now then we gotta check 72 to see if 72 is an answer as well. So bring this down. I check, apply back into the original equation. Square root of 72 plus 9 minus square root of 2 times 72 question mark is equal to 3. Okay, so now we gotta work this out. So this one becomes square root of 81 minus square root of 144 question mark is equal to 3. Square root of 81 is 9. Square root of 144 is 12. So 9 minus 12 is negative 3. Well, negative 3 is not equal to 3. Okay? Negative 3 is not equal to 3. So that means x equals 72 is not a solution. It is an extraneous solution. So there you have it. Your answer is x equals 0 for this problem.